Data structure using C++. Topic: stacks. So stack happens to be a linear list. It is not a non-linear list in which the insertions and also deleting an element happens to be at the one end, and you call that end the end from where you insert or you remove a data from the list. You call it as top, the other end being a bottom. So this is the first configuration of a stack, wherein you have four elements. So stack is a concept wherein the last inserted element will be removed first. So it uses the concept last in first out. So this configuration, you have four items: A, B, C, D. So top pointer points to D. So now suppose if I want to add an extra element onto this list A, assume that item E is pushed onto the stack, then the stack configuration would look like this. So the top end would change. After inserting, the top pointer will be incremented by 1. If you're working with the push operation, suppose if you're working with the pop instruction, then you are supposed to decrement this top pointer by 1. You have to delete the element, then you have to decrement. Whereas for pushing the element, first you have to add an element. First you have to increment the pointer, then at that position you need to add. Decrementing, you can delete the element first, then decrement the pointer. Okay, so this configuration B is obtained from A by inserting one element. So top is modified. Now you get C from B once you use a pop operation 3 times. By using pop 3 times, the configuration B gets modified to C. So finally you will be left out with only two elements. So bottom points to A and B is top. Okay, so then you have the abstract data type for stack. The ADT of stack has this many methods. So ADT, again, I talk about ADP. When we talk about ADT, it happens to be, it is not dependent on the programming language. It is independent of programming language, just the methods which you expect and the instance configuration will be addressed here. So here, instances for the stack is a linear list. Literally it is a list element, set of elements. So the instances are similar to set of elements. So the one end you call it as a bottom and one more end you call it as a top, and you modify the data through top. Top is the pointer which should be updated, which should be modified based on insertion on deletion, and this is the one end which gets changed, whereas the bottom end is not going to get altered. Now the operations you have for stack are empty, size, top, pop and push. So empty function returns true if the stack is empty. It returns false if it's not empty. Similarly, size returns total number of elements in the stack. Top would return back the element present at the position top. Remove the element. To remove the element from the stack, we use pop instruction. Top element. Similarly, push instruction inserts the element at the top position. See, so these are actually the ADTs which are required to design. Fine. Next concept we have here is implementation of stack using array based. We will discuss this program and also we will take one simple example, and let's discuss how these functions are called, which functions are called, and how it is going to get altered. So the starting line, you have a template class T. So this is made generic, that is to ensure that the stack elements are of any data type. The elements belonging to the stack is general. In general, it is not meant for integer, it is not meant for floating point, it is in general. That's why we are using this template T. And we use functions array stack. So first is your class constructor, and second one is your class destructor. Then you have a empty method, size method, and top, pop, and push. So array stack destructor function, it's defined completely. So what the stack which you have created, stack over here is the set list of elements, instances, all should be deleted. Since you're deleting an array here, so you are using delete square bracket stack, so it's used for deleting the complete list. Okay, and you have a bool empty, so it returns start top is equal to negative -1. So if the objective here, what we do is we use one variable stack point, stack top, and the stack top value we will set it to -1. Suppose if you're pushing any element, then this index, which we call it as stack point, has to be incremented, and at that position you will be pushing the element. So stack point or stack top, if it's set to -1, it implies the stack is empty. Simple. When you push one element, it will be inserted onto the position stack top. So stack top has to be incremented, so it becomes 0. 0th position you insert a value. Okay, so this is the initial configuration. Suppose if the stack is empty. Okay, now we use size, so this returns stack top +1, because suppose if we push one element, stack top would give you value 0. 0 plus 1, that's the size of the stack. So we require this to be returned. Stack top +1 will be the size of the stack. Okay, and the top function is defined as follows. Suppose the stack top is equal to -1, when would this function return empty? It returns empty provided when you create an instance of a stack. Suppose if the class name is stack here, suppose if I define stack space s, then you're gonna get stack top value as -1, because initially there is no element as such. Okay, and we use return stack of stack top. So if this stack top is equal to -1, it returns stack empty. If not, this is the element which will be returned. So suppose if you insert one element, then the stack top will be 0, so it will return stack of 0. So that's your top position. Suppose if only one insertion happens. Okay, so this is clear if I'm not wrong. Let's look at this later again by taking one example. The push function, again you have here, have got, first you check this condition. If the stack top is equal to -1, then you don't have any element to pop, to destroy. Directly print the message, as empty, stack empty. So stack empty is a function which has a message saying that the stack contains no element. Okay, then if not, if you have a element, then what you have to do, you have to decrement the object and also destroy that position. I repeat, you have to decrement the object and also you have to destroy. So first it is post decrement. So what happens, so first element will be destroyed, then it decrements. Okay, the pointer will be decremented and also it is going to destroy the data which was there initially. First value of stack point is destroyed, then it decrements. Okay, so this is push function. Just remember, pop will decrement the position. Stack top should be decremented, push stack top should be incremented. Push function we will look at later sector, and here we are using 3 arguments: stack top, array length, and stack. So what is the stack top? Stack top is an integer. It is an integer and we set it as -1 literally initially. Then it will be altered based on push or pop instruction. Then you have array length, which has the capacity, which has the stack capacity. Okay, and finally you have stack, T star stack. So what is the stack? Stack is a pointer. You create a pointer, then in the class constructor you're going to create a memory location using this pointer stack. Okay, fine. Now we will look at the constructor array stack. So here array stack, the constructor which we are using here is initial capacity. So you have array stack initial capacity. So what does this do? So let me go back to the previous slide here. If we define sorry if we define here, if we define array stack, the name array stack, and if the object is s, okay, with no arguments, then initial capacity will be by default set to 10. Okay, if not here, suppose if we pass array stack s of 20, then the initial capacity will be changed, so capacity would be modified to 20. That is the case. By default you can use, or without default you can give the argument here. So here array stack, you can avoid this is to print saying that if the capacity is less than 1, it will throw an exception saying that initial capacity must be greater than 0. So you can avoid this always, concentrate on this. So what we do is initial capacity will be equal to array length. Okay, and based on this array length create a array. So this is the instruction to create. So stack is equal to new t array. So when you are creating a stack, so you have initial configuration set, that's all, but no elements are not pushed on it. List is created, no elements are added, hence stack top value is -1, saying that you haven't pushed any element. The stack is empty, so this function is required. Finally we use push instruction. Let's look what push does. So here push, you have one circumstances wherein if the stack top reaches the array length. Suppose we create a list with initial capacity 10, and after using 10 insertion, or after using 10 push instruction, the array capacity will be over. So almost all elements are filled, you don't have any space in your array stack. So what to do in that case? You have to double the array length. For that we check this condition, if stack top is equal to array length -1, if it has reached the ninth value. Stack top is equal to 9 implies you have 10 elements. Okay, so 0 to 9, 10 elements. If that is the case, then chain the dimension, chain length of a t. So this is your array, and this is your previous old length, and this will be your new length. So we have talked about change length 1d when we were discussing about matrices. So it was used for doubling the array size. So here if 10 is your previous array, so after change length d, the array length becomes 20. So you have 10 more spaces created. Okay, so what can be done? At the element plus stack top, at 10th position element will be pushed. So you have now 0 to 10, 11 elements are added, so 9 more spaces are there in this list. So again after 9 more push instruction, then again this change 1d will be modified, so again the array will be doubled. So that way you can increase this. So better method it is. This is what happens. Now let's look at one simple example and we will wind, and later we will move on to stack linked representation. So you have now, let's try to understand this. Rather than stack, let's call this as array stack. Array stack int integer date type and s. Don't get confused, this is array stack. Okay, and the object is s. Okay, and first what we do when we create stack is, so suppose if I had an instruction below this as s dot top, you are going to go to this location, and here stack top, what happens when you use this command? So constructor with no arguments, this has constructor with no arguments, so automatically this function will be run. Upon running this, the capacity will be considered as 10 because you have not provided, so default it will take it as 10, and this instruction definitely is not valid. So this is the stuff which gets created. So create space with 10 for 10 elements, and stack top will be -1. So suppose if I insert an instruction over here s dot top, then you're gonna get a message because stack top is -1. So you're gonna get a message saying that stack is empty. This instruction has been worked upon. Okay. Later let's look at now what happens if I use s dot push. After this instruction you have s dot push of 10. 10 has to be inserted, so you directly go to the function push. Okay, so when you're over here, so this condition you check stack top is equal to array length -1. What is stack top? Stack top is -1. Is it equal to array length -1? No, you have space. So what you have to do, stack of plus stack top, so increment the pointer, so it becomes stack of 0, the element. You have two stuff. Okay, the next instruction what you have here is 2 minutes. Then you have s dot push of 20. So again when you use the instruction push, stack top is equal to array length, so change length.